Um, okay, good afternoon. Again, my name is Kevin Meynell, and I'm the manager of the Deploy 360 program at the Internet Society. So I was asked to give a presentation on a couple of interesting topics. Well, actually combining two interesting topics. I'd like to give an overview about the Let's Encrypt initiative, which is has already established a new free open source certificate authority with the aim of expanding the use of encrypted connections on the internet. But I also wanted to tie that into some work that we've done in conjunction with DNSSEC and DANE, and how that can also help improve the security credentials of the internet. But firstly, I'm going to just, before I get started on the actual subject at hand, just wanted to mention a little bit about the Deploy 360 program. So what we're aiming to do with this, it's been running about 4 years, I think, now. And it's aiming to be a bridge between the protocols created by the IETF, some of which are better known than others, but then also creating that link between the IETF and people who are actually deploying these standards on the internet. So that would include network operators, for example. So we're aiming to provide hands-on information on IPv6, DNSSEC in particular, increasing the use of TLS for applications is another area, and that's really the focus of my talk today. And then we also got a role in to improve the security of the worldwide routing system. So we go out and work with people who are sort of, pioneers in deploying these technologies, and then try to create some resources. And we also organise some workshops and just generally try to spread the word. So that's the URL. I won't go into that in too much detail because it's not particularly entirely relevant to today's talk. But I talked about some of these things, mentioned some of these things earlier today, so you can find more information at that URL. A bit closer, okay. It's very sensitive. Okay. Right. Yeah. So also we're also we have a regular blogs as well on technical topics. That's pushed out onto Facebook and Twitter channels. Be able to subscribe to that if you're interested. Right, again, this is related to IPv6, nothing to do with the talk. I mentioned these two tools earlier today. Some people asked me about them in the break, so I put up the URLs for this. I'd like to mention the NAT64 check, which is allows you to check whether websites will display over IPv4 and IPv6. It allows you to compare them, see if anything is broken, and also mention the BGP tool, which compares the BGP peering policies. I don't want to go into too much detail on those, too much detail about that, because that's not the subject of today's talk. If you're interested, though, then please follow up. Okay, so the Deploy 360 team, there are 4 of us. We sort of go out and do, let's say, technical engagement. We're available for workshops and NOGs and technical talks. We also organise our own workshops as well. But really, I just wanted to prove that we don't always go to sunny, warm places with blue sea. We actually went to the top of Mont Blanc there, and it was -10, so it's not all fantastic fun. I think, Sherman, you were there, right, as well? Right. I think, was it you that was complaining that it was very dense up there or something? It was really cold. But anyway, we've just got a new member of the team, Aftab Siddiqui, but he's mostly engaged in the Asia Pacific. Okay, on to the subject matter. So first disclaimer is that I do not in any way work for Let's Encrypt or represent Let's Encrypt. The Internet Society was a founding sponsor. I don't think we are anymore, actually. But one of the reasons that I'm keen to sort of promote this is I did develop quite a big PKI for the European academic networks, and that became a model for also for academic networks in Australia and in the United States as well. So I came up against a lot of the frustrations that Let's Encrypt is trying to address and solve. So I really wish this was around when I was setting up this service in whenever it was 2007 or 2008, because it does seem to address a lot of the problems and frustrations that I had. So that's where I'm coming from. Some of these slides are from Let's Encrypt. Some of them are from my colleague Jan Zorge, who did much of the work with respect to DANE. So just to give them credit for that. So what is Let's Encrypt? Well, it's primarily a free and open certificate authority, with the key difference that it's actually automated. The aim behind that is really one really firm aim is to basically encourage the adoption of TLS on the internet. So by nature, a lot of internet communications are not encrypted and they're not secure. TLS provides a way of doing that. It's not the only way, but it is a fairly widely used way. And most people will be familiar with this through using web browsers with the padlock icon that you see in the browser bar. You might often see the sort of green browser bar, which indicates an EV certificate, but most people will most likely have used TLS in some way. Obviously, that's linked to, you need to use TLS. It's generally used with a digital certificate on the server. You can also use it at the client end as well, but it's more common on the server end. And that enables you to establish your encrypted connection. These are normally issued, should we say, sold by a certificate authority. There are some other CAs around that offer these for free, but usually you pay a certain number of dollars for these, and they're renewable every 2 or 3 years. So that's where you get the generally, historically, traditionally have got the certificates from. So what Let's Encrypt is really trying to do is make certificates freely available for anybody who owns a domain name. So they see the sort of cost as being a barrier to the sort of widespread use of this. But they also see the sort of technical difficulties in the eyes of some as being a barrier to this as well. So what they want to do is not only offer free certificates, but also offer an automated way to obtain those certificates. So to simplify the issuing and also renewal of digital certificates. And sort of underpinning of this is that the automatic issuing and renewal protocol is being developed as an open IETF standard. So in principle, this is not restricted to Let's Encrypt, but any CA can adopt this, and you can use open source tools to. So you're not tied to one particular CA. So yeah, I mean, we already mentioned that the internet fundamentally has been insecure. that situation is improving. But obviously, unencrypted traffic can be read and modified either on the wire or at the client or server end. So TLS, that's the modern term for what has been known as SSL. SSL is now deprecated. We're now up to TLS 1.2. TLS 1.3 is very close to being standardized. I think at the last meeting at IETF it was either agreed or very close to agreed as a standard. So this is most commonly, as I said, most commonly used for HTTPS or web browsing, but it's also quite widely used as well in other applications as well. So around 55% of Firefox page loads are over HTTPS, and around 62% of emails received by Gmail use TLS. Now, of course, that isn't bad, but it also means that a lot of traffic isn't encrypted as well. So the aim is to have 100% of internet traffic encrypted. I mean, we had just a talk earlier today about, well, you know, who's reading our messages, and this is the idea behind this. But CAs are currently needed to validate domains and then link these to the public keys used to establish the encrypted connections. Okay, so I already spoke a little bit about the annoyances of getting a certificate. I have to be honest and say I think I'm reasonably technically clueful, but I found this a bit of an obtuse way of getting something. When you know what you're doing, it's not probably that hard, but if you're new to the business, it seems quite confusing with a lot of jargon, and as I'll come to, a lot of more complications with verification and authorization. When I was running the certificate service in Europe, we did try to come up with a simpler approach where we linked this to the issuing to identity federations, and that did simplify things a little bit, but we still had to deal with CSRs and that type of thing. Yeah, so this is a quote from a Cisco fellow who apparently couldn't work out how to do it either. So this is kind of the underpinning idea. Well, if a Cisco fellow can't work out how to do it, then what chance the rest of us? So yes, even if you know that you need a certificate, then you've got to work out where you get this from. So you go to you choose a CA, and there are a few of them. Can't remember exactly. I mean, maybe nearly 100 or something like that that are recognised. But then, yes, then you've got to choose which type. So you've got DV, OV, EV. It's confused by all kinds of marketing names, Pro, Gold, Platinum. When we were procuring one of the certificate services that I was running, we literally had CAs coming to us and saying, well, you know, you want the Platinum version because that's really good. We're saying, well, what does it mean technically? Well, you know, it's better. Well, not really, no. So, yeah, and how many people would really know the difference between DV, OV, EV? I do, but it took me a while. I already mentioned the CSR that you need to produce in some cases. And then there's often a manual verification process. And in fact, since there were the hacking incidents a few years ago, some of the larger CAs took it upon themselves that they will only respond to particular types of email address. So they may go off to hostmaster at organization.org or whatever. You better hope that you have control of that address, otherwise you'll never see the response. Some are requiring a publicly listed phone number, which is great if you're a one-person company. If you're a big university, well, yeah, good luck with that if they're phoning up the Vice-Chancellor's office. And then someone's saying, okay, you need a DUNS number. And then, well, yeah, what's that? Most companies have these, apparently, but not everyone knows what they are. Okay, so then you've got to pay. That's probably the easy part. And then you've then got to work out how to install your certificate. And then in 2 years' time, you have to remember to renew it. And many people don't remember that. And then it expires, and you get an error on your website or whatever. So, okay, so Let's Encrypt comes along. And this is an initiative of Josh Schoss and Eric Riscola. And this came up in an IETF working group. So their approach is to firstly offer free certificates, that helps, but really only to support automated processes to make this simpler. So it was established under the auspices of the Internet Security Research Group in 2013, and it's a not-for-profit. ISOC did provide some initial financial support to get up and running, although it's currently sponsored by 30 companies that have ongoing commitments to support this. And there's some really big names amongst those sponsors as well. So this kicked off in pretty much in December 2015. I went into production in April, following April. Okay, so CA is a CA, though. I mean, it's not. They've been around for 20 years, not quite 20 years, perhaps. What are they doing that's different from the other CA, apart from offering certificates for free? Well, the key, I think, is the Acme environment. So this is basically a standards-based API. To request, validate, and revoke certificates, so it can all be done through automated processes. And in fact, you have to request a certificate or manage a certificate through the Acme protocol. You can't do it any other way, and that has been done for deliberate reasons. So they do have actually, it's not they have produced the client software, it's the Electronic Frontier Foundation have produced that, but there is recommended client software, but there is actually a big long list of others. And as I said, this is currently going through the IETF to be standardised, and I think it must be pretty close to become actually being issued now as an RFC. So down to the detail. The Let's Encrypt certificates are actually domain validation, so that basically proves that the holder of the certificate has control over a domain. And that validation is undertaken through it's called challenge verification. So there's 3 ways of doing that. You can either put a file on your web server, which can be checked. There's DVSNI, which is you can provision a virtual host at your domain's IP address, or you can put a DNS text record in your DNS. And then one of the perhaps big differences from most CAs is that the certificates only have a 90-day lifetime. So the aim behind that is partly to encourage automation, but it also they consider it good practice to renew certificates regularly to limit damage from compromise or misissuance. And there's the issue of certificate revocation as well. That may have scalability problems. So actually, if the certificates are just expiring in a short time, then that removes the problem of actually needing to maintain lists of revoked certificates. So, as with all credible CAs, the end entity certificates are validated through a chain of trust that originates from a root certificate, which is known as a trust anchor. And that root certificate trust is established through the distribution of root certificates for operating systems or browsers. So the main certification, well, traditionally the main certification programs are the Microsoft, Apple, and Mozilla ones. I'd guess that Google is probably pretty big now as well. But those are the three classic ones that you kind of had to be in to be recognized. So the actual Let's Encrypt certificates are issued from an intermediate CA, which is called Let's Encrypt Authority X3, which is signed by another certificate, but that's kind of a common arrangement with CAs that you generally will have an intermediate CA. So if there's a compromise underneath that certificate issued by that CA, it doesn't compromise the whole PKI. So that root certificate has been accepted by Mozilla, Apple, and Google. I believe it's currently close to being accepted by Microsoft as well. But in order that it will work with other OSs and browsers that don't support those root programs, it's actually cross-signed by another CA. That's partly because when it started up Let's Encrypt, it wasn't accepted into any of the root programs. Well, it takes 2-3 years to be accepted into a root program and then have your root certificates propagated. So in the meantime, it was cross-signed by an existing CA so that it would be supported across a wide range of OSs and browsers. I already mentioned the Acme clients, and I already mentioned CertBot. So CertBot will support macOS and Linux and various Unix flavors, and it will also work with other CAs that will support Acme. I'm not sure how many actually do support Acme. I know there were some working on that. They're usually the smaller ones. I don't know if there's any large ones currently supporting that, but I imagine that will come. But there are other clients that support other platforms such as Windows, and there's a list up there. Okay, so how successful has this been? Well, it's been pretty successful. So really, given that the beta started in November 2015 and it only really went sort of production around April 2016, it's been pretty popular. So it's up to well over 30 million certificates have been issued in the past. Well, I guess it's about a year. Yeah, exactly a year, isn't it? So by some measures, this may be the largest CA in the world now. But it's certainly one of the biggest. It's certainly grown from being nothing to being very large. Is it actually encouraging people to use TLS? Well, yeah, the trend is upwards. It has been upwards since 2015. When it started, it was under 40% of. But I should mention here, this is Firefox browsers with using TLS connections. So it was under 40%. It's now apparently over 55%. Actually, this is even slightly out of date. So it has gone up. Whether this is directly attributable to Let's Encrypt is, well, you can debate, but there is an upward trend, which is good. Whether or not it's down to Let's Encrypt or not. Okay, but that's all very nice. Let's Encrypt is still a conventional CA. And one of the inherent weaknesses with CAs is that there are third parties and then in principle they can issue certificates for any name or organisation. And this has been a problem in the past. There were some infamous hacking incidents. There have just been simple mistakes. For example, I think there was a certificate issued erroneously to an entity for Microsoft and I think Google as well. And this is, definitely very problematic if someone else can masquerade as one of these large companies. And of course, as the more CAs that you add, and there's increasing pressure for this, particularly from national governments, because there's a number of national governments who want to have their own PKIs for various reasons, either for pride reasons or for control reasons or for whatever. And there's a sort of feeling that it's only the case that as the number of CAs increase, you run the risk of more potential weak links, and there's more chance that an incorrect certificate can be issued. So this is really, the big concern is if this happens with code signing certificates, because it's becoming more and more common that if you, in order to install software on your machine, it has to be code signed. So it's cryptographically asserted that it's from a particular manufacturer, and therefore, I wouldn't say guaranteed, but there's a better chance that it's not going to have compromised or be malware or whatever. So I think that's pretty common with the iOS platform, for example. Needs to be code signed applications. I think Android kind of impose it, but not strictly. But obviously, if somebody's actually signing a piece of malware as what appears to be from a legitimate software producer, obviously there's obvious consequences for that. So, although OV and EV are not code signing certificates, this problem was recognised a while back. So this is what prompted the consortium of root CAs to try to improve this process, which is why organisational validation and extended validation certificates were introduced to improve that. So that comes under the auspices. These are sort of semi-standard from the CA browser forum. So it's a group of nearly all of the big CAs in the root trust distributions come together and agree certain working practices and certain codes of practice. But yeah, with the OV and EV, it's still, you still have the problem of, it only takes one rogue issuance of a certificate and it compromises the whole system. But I think for me, the real weakness of OV and EV, although it does improve some of the checks, in fact, to a stupid level, in my opinion, in some cases, it actually still relies very heavily on users to actually identify that these certificates are being used. So, with an EV certificate, you see a green bar in your web browser. Okay, great, but do you know what that means? Does the user know that green means that's a higher level of assertion? And of course, then you have many more automated systems. We're very keen to encourage the use of TLS for email, for example, and that's something where there isn't really a lot of user intervention in that. How do you check for that? But actually, there was another problem with that as well with EV. So there was a really sort of deep, sort of in-depth probing of, does an organisation exist? Can you prove your identity and all of that type of things? But actually, this was a real problem because we had a particular problem with Oxford University. To give you an example, Oxford University doesn't exist on paper. It has no legal charter. It's not incorporated. It has not even any royal charter. It predates almost the existence of the country. So when Oxford University went to get an EV certificate from a well-known CA, it wasn't able to do that. It can't physically prove its existence. It's been there 1,000 years, but you simply can't. It simply can't prove its existence. Okay, so ways were found around this, but it was just really got quite silly at one point. So this is not a perfect system either, at all, not in any way. Okay, so those are the problems with the sort of current CA issuing system. But we sort of have a sort of ready-made, pre-existing PKI. It's called the DNS, or it could be called the DNS if you add DNSSEC. So as I'm sure everybody knows, DNS is the main method to locate internet services, and it has a particular advantage that it allows domain name holders to control the records related to their services. Okay, we could argue that to some extent, but it's generally that's the case. Then you've also got DNS security extensions, or DNSSEC, which allows users to digitally sign their DNS records. So, in principle, only the domain name holder can make those changes. Then those DNSSEC records can be validated through the chain of trust up to the root zone. So, if you make a query as a client, you can verify that the information coming back is from the entity that's authorized to make that. Of course, that doesn't mean the information is correct, because somebody might put incorrect information in the DNS, but yeah, you can't always work around those problems. But you can have reasonable assurance that that response coming back is information that's been entered in by the controller of the domain name. But yes, you can also use DNS. So whilst DNSSEC is primarily aimed at returning domain name queries, it can also be used to authenticate TLS client and server entities. And that's done through something called DNS authenticated name entities, or DANE for short. This is a really almost revolutionary development, and I'm kind of surprised that it really hasn't had much more take-up, because it in principle solves so many problems. I mean, I'll discuss a little bit why it hasn't had take-up, but for me, I would have really wished this was around a few years ago, because it allows certificates to be cryptographically bound to the DNS names. So the domain administrator can certify the keys used for establishing their TLS connection, their TLS sessions, by storing them actually in the DNS. So you're not relying on that third-party trust anymore. So in principle, a CA shouldn't be able to issue a certificate in any name. Well, they can, but that entity would still need to put it into the DNS, and would need to have control of that domain. So it's an extra check on the process. But DANE does, yes, it does require DNSSEC records to be signed with DNSSEC, and it uses a record type called TLSA, which associates a TLS certificate. It doesn't actually have to be a TLS certificate. It can be another type of public key as well. It associates the TLS information with a domain name. The clients do need to be DNSSEC and DANE aware, but that is increasingly starting to happen. That has been one of the barriers to deployment. In fact, been one of the barriers to deployment with DNSSEC, but that is the situation is gradually improving. Now, I already mentioned that it needs DNSSEC support, so from the top level domain. Many, if not most, of the generic TLDs should now be DNSSEC signed. The situation with the, well, and the reason for that they are signed, I think that is now a requirement from ICANN. But with the CCTLDs, there's a sort of varying levels of support for DNSSEC. The sort of green colours are not so great coming out on here, but the green is where there is, in principle, operational DNSSEC in the CCTLD. So it's some of the larger economies. It's supported. I did take a look at the Caribbean. The resolution isn't so great. So by the way, these DNSSEC maps we maintain at ISOC, so we update these from various information. We keep track of these, so there's one for each region. Fortunately, the resolution in the Caribbean is not brilliant, so I had to go and look individually. The situation is not fantastic. I did look at, I think Trinidad fully supports DNSSEC and with IPv6, so and Barbados supports DNSSEC but not over IPv6, I believe. Yeah, it supports DNSSEC but not over IPv6. You've got to do both to get the gold star. And I think Antigua may support it in some way as well. But anyway, sorry. Yeah. So there's a few, but it could be an improvement. But so that's the key. It needs to be DNSSEC enabled to start with. So I would encourage you to, anybody that's not from Barbados or from Trinidad, to go and badger your CCTLD. All right, so the DNSSEC TLSA record, these are as defined in RFC 6698. So they have this thing called usage selector and matching types fields. That kind of determines which CA certificates and hashes are acceptable. I've got a little one slide on some of the problems we ran into with this. For various reasons, Let's Encrypt recommends 211, 311. It doesn't matter exactly how all of this means. It is defined in the RFC. But just to give you an example, the TLSA record for our experimental domain is that's the actual record there, and it's more or less a hash of the TLS certificate, and that's what goes into the DNS. So, okay, why are things failing in DANE? Well, one obvious reason is that the TLSA record is published in a non-DNSSEC zone, so the data is untrusted. And the other reason is when the domain where the looked up records reside are not DNSSEC signed, so there's no verification. That's probably fairly obvious. The other common problem is the wrong certificate hash in the record as well. And we ran into that problem for testing. So we wanted to see, well, okay, what's the level of DANE deployment? And actually, we were just interested to see if we could get this to work. And we did. So we basically set up an experiment using DNSSEC. We used PowerDNS and OpenDNSSEC as a signer. We used Postfix mail server, which version was TLS support, which happened to be 3.0.1 at the time, although 3.2 has just recently been issued, and that tidies up a few things in Postfix. We used a Let's Encrypt certificate, so that was downloaded, and then from that we generated a TLSA record. And we used an application called ChainGen. So it actually wasn't that automated as we'd have liked. I have to admit to that at this point in time. But I think that side of things we can work on. So that record went into the DNS, and actually we then used that to, well, not just that, but that was part of the process to check whether any other domains actually actually had DANE support. So what we did, developed a script that went out and to the top 1 million Alexa domains, and then tried to send an email to each of those. And that was, the idea was to find out, well, who's supporting TLS, and then actually who's supporting DANE as well. So the results were quite interesting, actually. Amazingly, 70% of the attempted sessions were encrypted with TLS. So out of a million, or 700,000 were actually you could use encryption. I mean, we were quite impressed in a way with that. Of course, 30% are not, but great. And even more amazingly, 60% were established using a trusted certificate as well. So it wasn't opportunistic. Yeah. So then the remaining sessions were either using an untrusted certificate or some other. I'm not even using anything. I'm not sure how many were actually using nothing at all. It would have been 30% actually looking at that. Okay, but then the scary part, and bear in mind this was a year ago this was done, so it may have changed, but none of the top 10 mail servers and the domains were actually DNS signed at that point, so that wasn't a good thing. But that, in fairness, may have changed over the past year. Okay, but the thing that we wanted to find out, there were only 128 sites which could be verified using DANE out of a million. Room for improvement, probably, there. Okay, so we should mention some of the issues that we ran into. This is all actually very, if you're really interested in the detail, we've actually got 2 how-tos on our website, on the Deploy 360 website, which go into great detail about what we did with this and how it worked and how it didn't work and what we did to fix it. But one of the issues with Let's Encrypt is that the certificates are only 90 days, so in principle the underlying key is being changed when you're renewing. And that of course also changes the hash, so if you're planning to use the 3.1.1 version of TLSA, then that requires some extra effort. So the 2.1.1 records, they don't use the root certificate in the certificate chain. So in principle, well, not in principle, you do actually have to manually fetch that certificate and add that to your full chain file. But then the problem with that is then, okay, well, once you've done that, but what happens if the root certificate changed? Now, it shouldn't change that often, but it potentially can change. Well, it should change, actually, at some point. So we ran through various scenarios about this, so what happens, but we actually discovered that you can use the same CSR when the Let's Encrypt certificate is used, and then that means that the same underlying key can still be used as the hash isn't changing. So we don't sort of recommend that you never change that underlying key, but it probably doesn't need to be changed every 90 days. So maybe you could do that on a different schedule. So basically the problem was, if you don't do this, then something will break every 90 days. And we were running this as a test scenario, but we're running a lot of production systems, and this could be quite annoying. So we just wanted to highlight that some work is still needed, and this is another sort of non-automated process that that you need to be involved with at the moment. But it does work, and it's I think a good solution to the sort of third-party trust problem that you have with just using the certificate from the CA. Again, I said if the full details are all on our website. There's, I say, 2 how-tos which I refer to in this end of this presentation. So, okay, we come to the conclusions, the moral. So the situation with email is it appears that statistical sampling would suggest that 70% of email can be encrypted, sent encrypted in some way. So if you haven't done so, enable TLS on your server. Get this up to 100%. You can now get certificates for free from a credible and reputable CA. As I said, there are some CAs offering free certificates, or were offering free certificates previously, but there were some question marks around those, which we won't go into in too much detail. It's a bit of a controversial topic, but there's no excuse not to do it now. This should be possible. And actually, whilst you're not doing it, you're potentially also compromising other people as well. So it's a sort of collaborative security thing as well. DANE is not as difficult as it may appear, and there are some ways you can automate it. It does involve some scripting, but it's certainly not rocket science. But the one thing is that we can encourage people to do this, but we do actually need more DNSSEC signed domains. So we need people to take up that challenge. But ultimately, we need even more DANE supported servers as well. So this is the message that we're bringing, and please read the information, and please try and help us raise this figure. Right, so that's the last slide. So if you'd like more information just generally about Deploy 360, so it's IPv6, DNSSEC, and some TLS and secure routing stuff on there as well. That's the sort of focus of that. Information from Let's Encrypt at that URL, and then the how-tos from the experiments that we ran and how we fixed the problems. Not very, unfortunately, not very compact URLs, but you can also just go to the Deploy 360 website and just type in Let's Encrypt, and it should just come up in the search anyway, pretty high up. So that's it from me. Any questions?
Steve Spence, Kevin. I have two questions. If Let's Encrypt discovered that somebody's doing phishing and did a slightly different name to the organization name, is there a policy of revoking that as data certificate?
I honestly don't know. I don't know.
I heard a story about it. Somebody.
What was the story?
Somebody created a website that was close to another person's organization, and they were sending that as it looked close enough if you don't read it carefully enough. Because what most users do is that they look for the green lock, and once they see the green lock, they say, "Okay, everything all right." But was a misspelled. I think they changed some letter around, and the person said they reported to Let's Encrypt, and Let's Encrypt said that it wasn't their problem.
It's a difficult one. Yeah, difficult one. I can't speak for Let's Encrypt, so I think it's a good approach from the technical side of things as to the actual policies for revoking that type of sort of abuse. I think that's a the question would have to be directly addressed to them. I mean, I could certainly raise that. Yeah. And I mean, I'm not sure I'd have an answer for you even then, but I can put that to them.
Okay. Another thing is the encryption strength of TLS. How secure it is? Are we selling something that we're not too sure about?
Well,
so it's not reason I ask you that. People are kind of some people are concerned about security, and the motivation for doing this is to let's encrypt all internet traffic. But if your ISP collects your data and sell it to the government, will they be able to actually decrypt it?
Okay, so I've been following the discussions on TLS 1.3, for example, and I think 2048 the encryption is generally considered that it's not crackable or likely to be crackable for a foreseeable future. I'm not a cryptographic expert, so let me just qualify that. But I hear stories about 1024, and maybe that somebody might have come up with a way of cracking that, but it's all unverified. I think I can't give any guarantees. I'm not sure anybody can give any guarantees other than the people that are really working on this.
It's hard to break. It's hard enough to break that a sufficiently less resourced person would not be able to get it. But if you're if you're well resourced,
well, if you're the NSA, possibly. But unfortunately, I'm not party to that information. I'm not sure anybody.
Okay, we'll wait on WikiLeaks to drop
it. But from everything I've read, I mean, I think 2048, unless there's other weaknesses in the actual algorithm itself. But the guys in the TLS working group seem pretty
confident about it.
Well, they've removed some of the algorithms from the new specifications, so there might have been concerns about that. But with 1.3 spec, they seem to be confident. So
okay, good.
It's a matter of trust, I guess.
Massimo Candela, RIPE NCC. First of all, thank you for the great presentation. I have a question related to the chart about the adoption of certificates. Two questions about that. The first one is, I see that there is at some point a bump and it goes down again. Is it one of the issue about the breach that you were talking about? Do you know about what it was in particular? Yeah. Oh, that one. Yeah.
Yeah, I don't know. I mean, I assume this is being sampled in some way, so maybe there was some. When would that have been? That's sort of September, right?
Yeah, beginning. Yeah, it looks like kind of. I'm curious about it because it looks like it goes up, and after someone regretted something.
It's a good question. I have no idea. Weirdly, with other things like this, you occasionally see these weird dips, and maybe I assume this is being sampled in some way. Maybe like the sampling system, didn't function properly or broke or something like that for that period. I honestly don't know. Honestly, have no idea.
The second question is about if you have data or anyway, if you know something about the conversion rate. So after Let's Encrypt started, how many domain, let's say, they moved to use Let's Encrypt compared to other CA?
Yeah, that's a good question. I don't know the answer to that either. I could find out.
Okay.
I will find out. But I
Thank you very much.
Sorry.
Thank you very much.
Great talk, I'd say. Thanks, Kevin. This is more just a general comment back to the community, just to encourage those of us who have not, who don't use Let's Encrypt or some services like that, to go ahead and try it out. Been using it myself for a while with really good results. Not only, key for me is not only is it the securing of URLs and so on. I'm involved in a lot of application development, so all apps and endpoints for APIs and so on want to have those on secure links. But not only does it kind of sort that out without having to go out buy an expensive cert, but the 90-day renewal policy actually for us works well because it demands automation out the gate, and so we have automated ways to provision applications from day zero, deploying an absolutely new code on new apps on a new web server. And part of that is to go get the cert, install it, create the web server config files, all of those kind of things in just automated and scripted ways. And it changes the, for us, changes the dynamic of just the cost to deploy and support applications because it requires a particular kind of discipline. And so I'd encourage operators and people who are in this space to look into this and also just track the space generally. As Kevin said, the automation behind it is not exclusive to Let's Encrypt. It's an open source project. It's something that we can track and make use of and move more and more towards more automated deployments.
Yes, a question, Jason Hines, or comment and question. So I've noticed that in moving around and connecting to some Wi-Fi networks in hotels and other places, that the move by some websites to encrypt have actually been inhibiting my ability to connect because the captive portal was not allowing HTTPS traffic through, and typically I have to think of a non-encrypted website to try to connect to so I could authenticate to the captive portal or click through to whatever. And I was just wondering what your comment on that. That seems like it's a deployment problem that people are having, and I think operators need to address it.
Yeah, it is. Yeah, I mean, I suppose part of this is to go hand in hand with encouraging, that HTTPS not to be blocked. Yeah, that's a fair point. I guess, well, my solution is a tunnel, but so I've got tunnels all around the place, so sometimes it gets me around the problem, not always. Yeah, I mean, I agree. It's that is a potential problem. I mean, I think this, and this is done deliberately as well. Sometimes, I mean, there's some, there are simply some, shall we say, jurisdictions that just simply don't want encrypted traffic. In fact, even in my, although not specifically related to TLS, even in my own country now, there's this move now to try to ban encryption on, or to restrict encryption on the wire, or at least give the government security services backdoor access to that. So I think this is we're trying to reach an optimal scenario from the user point of view, but of course there are other elements that we'd rather we don't do this, or would like to restrict this, and I think that's the sort of juggling, balancing, persuasive act that we have to work on.
Thanks again, Kevin.